Continuing with section 8.4, in part 2 we're going to do examples 4 and example 5 from the guided notes, and I'm going to do one more problem with you from the textbook. So we're going to do 3 problems together here in this video. My first one, I'm still doing the partial fraction decomposition. This time I've got this denominator that needs to be factored. With it having 4 terms, we're going to try to factor using the grouping method. So I'm going to do some scratch work over on the side first. And I'm going to look at how to factor the x cubed plus x squared plus 4x plus 4. The grouping method, I look at the first 2 terms, and I see that I've got a common factor of x squared. That leaves me with x plus 1. In my last 2 terms, I have a common factor of 4. That leaves me with another x plus 1. So now I have a common factor of x plus 1 that I can pull out of each of these terms. And I'm left with x plus 1 times x squared plus 4. So we can now replace the denominator with the factored form, giving us so we now have 5x squared plus 3x plus 13, and then the denominator is going to be x plus 1 times x squared plus 4 equals, we have factored our denominator as far as possible. The x squared plus 4 is a sum of squares, so that's not going to factor any further. So we're going to break this apart into 2 separate fractions. And in our first one, our denominator will be x plus 1. Because this denominator only has x to the first and nothing higher, we just put a single constant, a, in the numerator. My second fraction will have the denominator x squared plus 4. And this is the new piece that we're seeing today versus the last time. My denominator has an x squared term, even after everything has been completely factored. If my denominator has an x squared term, my numerator needs to have an x. So my numerator will become bx plus c. And now we're ready to solve for a, b, and c. So the new piece again is that with this denominator being completely factored, we were left with this quadratic, this x squared. And our numerator needed to have an x to the first, so instead of just putting a single letter in the top, we had to put a bx, and then we had to put another constant. My common denominator is x plus 1 times x squared plus 4. We'll multiply both sides by the LCD. That would give us 5x squared plus 3x plus 13. Here we'll multiply by the common denominator. The x plus 1's will cancel and leave us with a times x squared plus 4. And here when we multiply by the common denominator, x squared plus 4 cancels. We're left with our numerator bx plus c times x plus 1. Let's distribute on the right. We have ax squared plus 4a plus bx, so we distributed the ax squared plus 4a. Now we're going to FOIL the 2 binomials over here. So bx times x will give us a bx squared plus bx plus cx plus c, just foiling the 2 binomials. We'll just bring the left side down. And now we just find all of our x squared terms on the right. So we've got the x squared terms. If I combine like terms on the x squares, I get a plus b, the quantity a plus b times x squared. If I find x to the first terms, combine these, I get quantity b plus c times x. And then the constants that are left are the 4a and the c. And I'm just going to put those in parentheses as well. Now I can set up my system of equations. Okay, I I'm sorry, I ran off my screen there. So let me leave that there for a moment while you look at what I've done. So I'm left on the right side, the quantity a plus b times x squared plus the quantity b plus c times x plus my constant is 4a plus c. Now I'm ready to set up my system of equations. And I'm going to do that by setting the coefficients equal. So I've got on the left side, x squared has a coefficient of 5. So 5 is equal to a plus b. 3x, so my linear terms, my x terms, I have 3 and b plus c. So 3 is equal to b plus c. And with my constants, I have 13 on the left is equal to 4a plus c on the right. And now I'm ready to solve these. So I'm going to start by solving my first equation for a, and then I'm going to substitute into the remaining 2 equations, or maybe the remaining 1 equation. But if I solve my first equation for a, I'm going to subtract b on both sides. So I've got 5 minus b equals a. So I've just subtracted b on both sides of that first equation. That gave me 5 minus b equals a. This can be substituted into this bottom equation down here, and then I can solve for c. So I'll have 13 equals 4, parentheses, put in the 5 minus b, and add the c. So I substituted 5 minus b into this last equation for a. Here I can distribute, giving me 13 equals 20 minus 4b plus c. Subtract 20, so I'll get negative 7 equals negative 4b plus c. Alright, and then the middle equation that I didn't use yet, 3 equals b plus c, has the same variables that I have here, so I can solve those together. So I'm going to write a new system, 3 equals b plus c, and I've got negative 7 equals negative 4b plus c. So that they're all lined up, and I can solve this system for b and for c. To do that, I'm going to multiply the bottom equation by negative 1. That way I can eliminate the c. So I'll have 3 equals b plus c. And then the bottom equation I've got 7 equal positive 4b minus c. Okay, and now I can add these together. That'll give me 10 equals 5b, and my c's cancel. Divide both sides by 5, and I get 2. So b equals 2. I can find c. If I back substitute, I can put it in this equation. I've got 3 equals 2 plus c. Subtract 2, so I get 1 for c. And now I can find a. If I go up here, I know that 5 minus b equals a, so I'll have a equals 5 minus 2. So a equals 3. So now that I've found a, b, and c, my final answer would be a result of replacing the a, the b, and the c with these numbers that I just got down here. So my final answer will be, I'm going to have to go to the next page. My final answer is 3 over x plus 1 plus, for b I got 2, so 2x plus c is 1. So 2x plus 1 over x squared plus 4. So I got 3 over x plus 1 plus 2x plus 1 over x squared plus 4 for my answer. For example 5, we're going to find the partial fraction decomposition for 4x cubed minus 2x squared plus 7x minus 6 all over 4x to the 4th plus 12x squared plus 9. We again need to start by factoring our denominator. So to factor that denominator, I'm going to do scratch work on the side. Okay, so you've got a trinomial, and you've got rather large numbers to work with, so you might want to go to the A times C method to help you factor this. A times C method tells me to multiply the first coefficient and the constant. So 4 times 9 would give me 36. And then I need factors of 36 that I can add or subtract to give me my middle term 12. So factors of 36, I could use 6 times 6. I can use those numbers to rewrite the middle term. So I'm going to have 4x to the 4th plus 6x squared plus 6x squared plus 9. Now it's 4 terms that I can do the grouping method. So looking at the first two, I can pull out 2x squared. That leaves me with 2x squared plus 3. And here I can pull out 3, and that leaves me with 2x squared plus 3. Now I have a common factor of the 2x squared plus 3. Pull it to the front. And I'm left with 2x squared plus 3 on the inside. That gives me 2x squared plus 3 times itself, or 2x squared plus 3 quantity square. So I'm going to replace my denominator with the factored version of this. Just rewriting the entire fraction with the new factored denominator. And now to set up my partial fractions on the right, we notice that we have a square here. That tells me that I'm going to have two separate fractions. I'm going to have to use this factor by itself, and then I'll use it a second time with a square. So we know we're going to have two fractions over here. Also, on the inside, we've got another quadratic. We've got an x squared on the inside. So that is telling me, just like in the previous example, that when I set up my numerators, I have to have an x term in the top. So my first denominator is going to be 2x squared plus 3. And in my numerator, I need to put ax plus b. My second denominator will be 2x squared plus 3 quantity square. And it also needs to have the x in the top and a constant, so it's going to be cx plus d. So even though this is a larger problem to work with, the work itself is not going to be as bad as it may seem at first. So to get going with this, let's multiply both sides of this by the LCD. And of course our LCD is the 2x squared plus 3 quantity square. So if I multiply the left side by the LCD, I'm just left on my numerator. Multiplying the right side by the LCD, I'm left in the first one. One of the 2x squared plus 3 factors will cancel. So I'm left with ax plus b times 2x squared plus 3. And then in the last fraction, I'm going to multiply, when I multiply by the LCD, the entire LCD cancels out and just leaves me with the cx plus d. So I do need to FOIL this piece, and then I can work on getting things rearranged. So when I FOIL, that's going to give me 2ax cubed plus 3ax plus 2bx squared plus 3b, and then add the cx and the d, and bring down the left side. Alright, now we can work on getting things together like we need them. On the right side, I can rearrange a little bit, so I can write this as 2ax cubed plus 2bx squared, and then 3ax and cx, those are like terms, so it's going to be 3a plus c times x plus, and I have a constant of 3b plus d. Just bring down the left side. And now I'm ready to set up my system of equations. So with my x cubed, I've got 4 equals 2a. With the x squared terms, I've got negative 2 on the left equals 2b on the right. With my linear term, x, I've got 7 equals 3a plus c on the right. And my constants, I've got negative 6 on the left equals 3b plus d on the right. And we're ready to solve these for our variables. Our first two are easy. So 4 equal 2a, divide both sides by 2, that gives me a equals 2. My second one, divide by 2, I get b equals negative 1. And then for the last two, I can substitute my 2 in for my a, and I can substitute my negative 1 for my b. So this third equation will be 7 equals 3 times 2 plus c. Seven equals 6 plus c, subtract 6, and I get 1 equals c. And for my last equation, I have negative 6 equals 3 times negative 1 plus d. So negative 6 equals negative 3 plus d. Add 3 to both sides, and I get negative 3 equals d here. So for my final answer, I just need to put all these numbers back into the decomposition that we came up with at the very beginning. So my final answer will be 2x minus 1 over 2x squared plus 3 plus c is 1, so x plus negative 3 or minus 3, because d was negative 3, x minus 3, over 2x squared plus 3 quantity square. And that is, I'm sorry, let me rewrite that. That's squeezed in pretty tight there. So my answer came out to be 2x minus 1 over 2x squared plus 3 plus x minus 3 over 2x squared plus 3 quantity square. And that's my answer for example 5. The last example that I'm doing with you is a little bit different from the ones that we've done so far. In number 42, this is like number 41 in your textbook homework. You'll notice that the degree of the numerator is larger than the degree of the denominator. That means the denominator can be divided into the numerator. So we're going to approach this one a little differently from the other problems. We're going to first do our division, and then we'll do the partial fraction decomposition of the remainder that we have. So doing my long division, now also, can I do synthetic division with this? I'm going to set it up as a division problem, but how do I know if I can do synthetic division? Well, I'm dividing by x squared minus 9. You only get to use synthetic division if you're dividing by x to the first power. So because I'm dividing by x squared, I have to do the long division method. So on the outside, I'll put the x squared minus 9. On the inside, I've got a 2x cubed. And then it's got negative 19x. And remember, when you're doing long division, you have to have every power represented inside your in the division, in the divisor on the inside. So we need to have an x squared term in here. So we'll put 0x squared minus 19x and minus 9. And then we can do our division. So we start by looking at the first term on the outside, the x, or the first term of the divisor. What would I multiply x squared by to give me 2x cubed? I would need to multiply that by 2x. So 2x will go in this x to the first column. Multiply back 2x times x squared gives me 2x cubed. 2x times negative 9 gives me negative 18x. And then remember, your next step is to subtract, so I'm going to change my signs and add. These cancel. The 0 just comes down as a 0, and then the negative 19x plus 18x gives me 1x. Now I can bring down my negative 9. X squared is too big to go into x, so x minus 9 is my remainder. That means that so far my answer is 2x plus x minus 9, the remainder over the divisor, x squared minus 9. Okay, so far so good. We got a quotient of 2x. Our remainder was x minus 9, and we would write the remainder over the divisor, so we've got x minus 9 over x squared minus 9. However, we now are going to do the partial fraction decomposition for this fraction. And our final answer will still have this quotient of 2x as part of the answer. To do this, we look at the factored form of our denominator. So that denominator is x squared minus 9. That can factor as x plus 3 times x minus 3. So we can write this as, I'm just going to focus on the fraction, and I'm just going to make sure I don't forget about my 2x as part of my answer. So I can write this as x minus 9 over, and then I'm going to factor x plus 3 times x minus 3. And then on the right side, I'm going to break it apart into two separate fractions. And it's going to be a over x plus 3 plus b over x minus 3. So my LCD is x plus 3 times x minus 3. I'll multiply both sides by the LCD. I'll have x minus 9 equals a times x minus 3 plus b times x plus 3. I can now distribute so ax minus 3a plus bx plus 3b, and I can set up my system of equations as on the left side the coefficient of x is 1, so I've got 1 equals, on the right side the coefficients are a plus b, and then for the constants I've got negative 9 on the left equals negative 3a plus 3b on the right. And I can now solve this system. I can multiply the top equation by negative 3. So I have negative 3 equals negative 3a minus 3b, and I have negative 9 equals negative 3a plus 3b. Adding these, my b's will cancel, so I've got negative 12 equals negative 6a. Divide both sides by negative 6 and I get a equals 2. And then I can back substitute, and I'm going to have 1, going back to this equation, 1 equals okay, apologize for that interruption. My battery just went out on me. So I had just solved for a. I got a equal 2, and then I was about to back substitute 2 back into this equation for a. So that was giving me 1 equal 2 plus b. Subtracting 2 on both sides, negative 1 equals b. So taking these two values now and going back to what we had up here, our final answer is going to be 2x, our quotient, plus 2. So we're going to do a over x plus 3. So 2 over x plus 3 And then b is negative 1, so that's going to be minus 1 over x minus 3. And that's our final answer. 2x plus 2 over x plus 3 minus 1 over x minus 3. And this completes section 8.4 of partial fractions. And I will see you guys in class to work on this. Thank you very much.